Hello, I hope you are doing great. Today we're going to see how to create C# source generators. So, what are they? Basically, they allow you to analyze your code and generate C# or generate source code based on the analysis that you are performing on your code. They are actually analyzers, as the name say. I'm sorry, they are analyzers. They behave as analyzers. You analyze your code and you can create classes at compile time depending on the actual analysis you perform. Okay, so let's see. The first thing you need to do is you need to create a project in .NET Standard. Currently, only .NET Standard is supported for the actual project that has the implementation of the source generator. Your consumer projects can be created in .NET Core, for example, but the actual project where your main logic of the source code execution needs to be in .NET Standard. Yeah, you need to add the lang version preview, right, as I was saying. In the projects that are going to reference your source generator, you also need to specify lang version to preview, and you need to add a project reference to that source generator, and you need to edit your project file manually and set or add this to values to the reference. You need to specify that the output item type is an analyzer, and that the reference output assembly, you need to set it to false, right? You also will see that in this case, for this demo, I have these two values configured. This is recommended not to do, but this is useful for debugging scenarios. What's the thing in here? When you generate code using C# source generators, by default, there is no file emitted on disk. They are generated on memory, right? So basically, you won't be able to see what the files have. But when you add these values, you are basically saying that you want to emit the generated files on disk, right? And you specify where they are going to be persisted. As I was saying, this is recommended not to do, but it is very useful for debugging purposes when you are generating your library. Okay, so how do we create code? Basically, we have a class that needs to be marked as generator and needs to implement the iSource generator interface. This interface has the signature for the execute method, which has the access to the context, and with the context you basically have access to all of your compilation context. You have access to the additional files, the analyzer configuration, the compilation, right? The syntax trees, options, the assembly, pretty much everything in your compilation context. Okay, this is effectively executed when you compile your application, right? So if I go on here, reveal, in this case, you will see that some folder will appear here, and you see this generated files folder was actually created, and I have a couple of files generated.cs, roles.cs, users.cs, and a class in there that actually I don't know what it is. So it has that. I think I may know what it is. We'll see in a second. So you see that it actually generated all of these classes. So now in my here I can use those users, new users. Let me see. Yeah, it's public. Okay, I should be able to use it. Now you will see that in here it didn't recognize it, and let's see if it's because of this. So currently, when you have your analyzers in the same project, you basically have to restart Visual Studio for everything to refresh, right? And you see that I restarted Visual Studio, and now it actually found my users classes, my user class, it found my role class, and the other was, yeah, the demo class. They are in there, and now if I compile, everything should succeed. Okay, one fail. Let's see which one fail. Identifier expected. It says it is on. Okay, it's on the CS. I think that's because I have, yeah, I am using this file, and I have a blank line in there. So I think that's why it actually tried to generate the way it generated the .cs. I forgot to evaluate in the generator if the text was empty. We shouldn't. That was just a mistake. Okay, so that's basically what you do, how you create classes, right? And now if I want to create like more things in here, I can add more properties, right? Then you can add inheritance, you can add pretty much whatever you want, right? This one is going to be of type, let's see, double, was it? So let's see. Okay, it failed. Let's see why. It says double could not be found. So let's see. System.double. Okay. I can either do this, or I can add the using at the beginning of that class. Okay. And now you see that that was in this one here, right? This property. This one was bool, right? This one was a string. Okay, and let's see how that goes. Does not contain a test. Well, first the name is wrong. Property 3. Test generator. Public system test property 3 gets set. Okay. Let's delete this. Let's rebuild and let's see what it generated. Test property 3. Let's go to let's go here and let's see. Okay, it says all succeeded, and Visual Studio didn't recognize it because of what I was saying. Since I have that in the same project, we need to refresh. Hopefully they change that in the near future, because that's really annoying to be restarting Visual Studio. But there you go, there is the property. Now this is just a small sample, something really basic that doesn't really make much sense, right? However, we are going to see a small a more complete example and what we want to do. So here I have a test project that basically it has a generator that it's going to inspect a text file which has the URLs for JSON specification, or sorry, Open API specification for some APIs, right? And it will generate the client classes for those APIs. So the first thing that we have in here is, of course, the generator. We already saw this. It needs to implement the C Source Generator, and we have the context, and we have the execute method. You see that here we have the, okay, it navigates through all of the additional files, right? And now if the additional files are of type generator additional text, it will get the text. It will iterate through all of the lines. I know that the lines will have the URL. Then I get the string in here. We get the JSON, which is the API specification, and now we generate the classes from the Open API JSON string. And basically we are using the Microsoft Open API reader to be able to read JSON easily. And we get the Open API document, we navigate through all of it, right? We get the class name from the title, we navigate through all of the paths, right? So here we have the operation name, then we go through all of the operations, which are going to be the methods, right? We evaluate the parameters, the type they are. If we find boolean, they are going to be bool. If we find an array, we need to convert it to an object array. Otherwise, we use the schema type. We may be missing some validations, but those are the ones we have so far. You see that the method parameters currently are an HTTP client, the cancellation token, right? And the method signature is going to be public async task using generics, right? And we pass the method name. It will be generic too, and we pass the method parameters, right? And all of that is the body. In this case, I am assuming at the moment they are gets, right? But that will probably also need to be evaluated if it is a get, if it is a post, right? And change the actual code execution based on that, right? The code basically is request URL, right? The result we'll just get it, and we take advantage of the generics to do this method as generic as possible, right? And so the consumer or the user consuming this can use or implement their own models. And here we have how we build it. Now this is uh, a test project. Basically, you pass the file name, you uh, create the generator instance, right? You create like a new additional generator additional text, which is a custom class that I created, which generates from additional text, right? And that was just so I could compare the specific type. Uh, because I think I forgot to show you something. Okay, I don't think I have in there. Okay, let's continue. Um, so yeah, we do the generate additional text, right? We add it, we create the generator driver, which is going to be a C# generator driver. Uh, we create a compilation. In this case, you should pass a script, or if you have nothing, you send nothing. In this case, since the only thing I care about is to understand the additional files and not the actual code, I just pass an empty string, and then we run this. And now when we generate this, we will get um, the compiled classes. You already saw them created, so you know that you will be able to see it. Okay, it will parse everything, and you see that it's going to try to add the source, and which is the class. You will see that if I go and see this class, it has like using system, the HTTP JSON, HTTP threading tasks, right? It has namespace, pt, the generator, auto-generated, books APIs. You see that it has public async task, the output. Oh, this has a post actually. Post analyze book from Word file, right? Receives the source file URL, the email address or the results, cancellation token, the HTTP clients, right, etc., etc., etc. And the version book, this, and this is the code. You see that this one is an interpolated string that will be replaced with a version that should actually come as a parameter, which I didn't add, I think. Let's see. It should be in there. Oh, here it is. Version. Okay. And if there's an exception, it catches and throw, right? And that's basically the generated class, right? It will do it for like 3, I think. And then if we go to the output compilation, you will see we are able to see all the information about the compilation output, and in your syntax trees you will see the classes in here, the books APIs, the media APIs, and the customer finder APIs. So that's basically a small sample of the things that you can do with C# source generators. I hope this has been useful. Thank you very much. Remember to share the videos, share the channels, and let us grow and get more subscribers so we can keep growing. Thank you very much.